Good afternoon. Am I audible at the back? Is the mic working? Super. Thank you. Thanks to the IoT Next organization for giving me this opportunity to be present here. While he introduced me as being the Senior Vice President of Vodafone, I'm actually not here in that capacity. I represent this organization called the IET, the Institution of Engineering and Technology, who are the education sponsors for this event. So the session that I would be handling for the next 20 minutes or so is actually around networks for smart cities. So people, I think, assume that because I work for a company that provides connectivity, I should be some sort of an expert on that one. Okay, I am not. And specifically, they wanted me to focus on low-power wide area networks, LPWANs. So I thought we can do this more as an interactive session. I would, of course, put some slides on the screen more to sort of land a few points. But I would be very much interested in hearing from the intelligence, the collective intelligence of this room in terms of where this whole technology and connectivity is headed when it comes to the context of smart cities. Are we good? Yeah, we're comfortable? Okay. So before we start, a couple of, okay, this is what the agenda looks like. I'll introduce the IET, just so that you're also aware of what organization I represent today. Little bit on the connectivity itself for the Internet of Things. What is happening in terms of trends, markets, areas are growing, and so on, and what rates will they grow at. Little bit about smart cities and services. This I'll skip through quickly because I think enough speakers today have actually put up different slides in terms of what are all the services that can be delivered as part of the smart city initiative. But I'll put one slide just for context. A couple of slides on smart city networks. And then a little bit of discussion on low-wide networks, or LPWANs. Okay? 20 minutes. Please feel free to ask a question at any point of time. Okay, so I'm comfortable with people asking questions. The standard protocol, the signaling protocol is you put up your hand and then say Joy. Joy is my name. Okay? It's Joy Rajan Cheruvathoor, so don't worry about the rest. Joy, put up your hand so I know where the question is coming from. Then just go and fire your question. Okay? It's not just questions, even comments, thoughts, ideas, anything are welcome. Is that okay? Super. Okay, so we are, as IET, we are a 144-year-old organization. We are a global professional body. We are based in the UK. And in terms of memberships, the Institution of Engineering and Technology is maybe second to just the IEEE. Otherwise, we are a global organization with a huge membership. And this is what we do. We are actually present, we are headquartered in the UK, but we have centers in Bangalore, in Peking or Beijing, in Hong Kong, in New Jersey, and all over the world. And most of the members the working members are actually students, people in this organization at that stage of their lives, and then they grow with the organization. The fundamental difference between the IEEE and the IET, if I may say this, is the IET actually is a qualifying body as well. So that would be the difference that I can think of. In India, we are focused on these three sectors. One is the Internet of Things. So there's a separate focus by the IET on the IoT. Okay? I'm part of the panel that is there in India. We also have a huge focus on renewables and solar and on urban development and electromobility. Just to give you a sense of how we are structured, in the IoT panel of the IET, we have a global advisory board. There are people like TV Ramachandran who are part of the global advisory board of the IET. We have a core panel. I'm a core panel member. And then we have 8 groups, working groups that work on these different areas. So 4 are vertical focused and 4 are horizontal groups. Okay. With this, I'm moving to the topic at hand. Any questions on IET? None. You have one, okay. Transportation, no. As an area, no. We are not focused as of now. We have a working group that touches on transportation, but not as a separate area. Okay? But I would like to engage with you if you feel that it is worth an IET focus, okay, after this session. Super. Okay, so I'm just moving on to the IoT per se and what comes in the area of connectivity for the IoT. These slides would be available for you to download and look at on SlideShare and on my LinkedIn web page, and I guess on the IESA website as well. So don't worry about these slides. If you're taking photographs, take them of me, not of the slides. Joke. Okay. So the future of things is connected. This actually is material that I had picked up from the Indian Express of about 2 weeks ago. Basically, the takeaway from this slide is just 2 points. I thought I'd just land these 2 points and then quickly move on. The first one is that the IoT is growing at a humongous pace, and 41% compounded annual growth rate is nothing to be sneezed at, right? It's a huge growth area, and probably that's the context of why this event itself is all around the IoT. It's an area which is growing tremendously. Different people have different takes on what the size of the connected market will be. This, I think, is around 25 billion number of connected devices is what this study seems to point at. Different people have different takes on it. Some of them go to trillions and stuff like that. That's just the left-hand, the graph on the screen. And on the right-hand side, I just want to call out a couple of points. So we've actually tried to look at the investment and the growth that can come from different parts or different sectors of sectors. So the ones in blue are actually the investments and the number of connected devices that would be with pure consumers. The one in red, the circle in the red and the triangles in the squares below that, are the investments and the ROI for government. And the third is the investments and ROI for enterprises or companies. Just some data points which I thought I'll land with you before we move along. This is more of a baselining in terms of where we expect the investments to happen. And this is courtesy the Indian Express, okay? So just one slide on what I believe would be smart city services. So like the speakers before me said, there is a human being who would be in the middle of this whole cycle. There would also be infrastructure that needs to be planned and tracked and monitored. So the whole concept of smart city would come around smarter buildings, smarter transportation, education, healthcare, public safety, and of course, agency administration. There's a little bit on tourism, travel, and everything else. And the more important part of this slide, I would like you to focus on the piece on the right, which is not very legible, but what I'm basically trying to drive here is to give you a sense of the kind of connectivity that would be required to get all these services up, running, updated, current, responsive, name it. All this has to be delivered by appropriate connectivity. That's the only point I wanted to drive through this slide. Any thoughts on the services at this point? Any reactions? Okay. I'm just moving into the nuts and bolts now. So if a smart city has to deliver to those goals, which we talked of a little while ago, then these are the kind of networks that come into play to deliver these services. So I'm reading from the top down. You have the wide area network. These are typically used to define networks that are global, that are citywide, really covering large areas, large spaces, usually provided by telecom companies. Then you have something which is called as a metropolitan area network, or the MAN, okay, which typically covers the area of a city, say 25 kilometers or so. Then, of course, you have the LAN, which we are all familiar with, which covers a building or an office or a campus. And then you have the personal area network, which is what we have, say, 10 meters around us, which would be addressed through say, Bluetooth or Bluetooth low energy and stuff like that. And here are the technologies also. So, and the standards that govern these different kinds of networks. This is just to give you a sense of the kind of networks that we employ, especially when we bring up something like a smart city. Having said that, look at this slide on the right. Okay, this is actually from Machina Research, and look at the kind of growth that they are projecting for the short range. This is not specific to smart cities. This is for all IoT, but I just wanted to draw a parallel with smart cities. So the way smart city services would finally get delivered would result in a huge growth of the short-range connectivity, which is this side of the graph. So this is what the short-range connectivity is growing at. The one in red is the cellular. The one on top of is the wide area or the fixed network. And the one on top is actually the metro area network. So just to give you a sense, so the highest growth actually would happen in the short range areas. Now, current technologies, when we talk of short range, they are actually, we also use them interchangeably for low power kind of networks. And in a smart city kind of context, what it actually means is connectivity that can transmit data over larger distances or longer distances, but consumes less power so that the sensor can be alive for 10 years or more on one set of batteries. So you don't really need to go and change batteries in a sensor. In the case of, say, a parking area sensor, okay? So if I can have a sensor that transmits only when a car comes in and when a car moves off, and nothing else at any other point of time, it just sleeps, I can actually have that sensor, and if it's in some remote parking lot, which is and the sensor is battery powered, then I can actually have a situation where the sensor has a life of 10 years, up to 10 years. So that's the kind of thing that we're looking at. Rain monitoring, wide area, maybe once a day, shipped back, and the sensor, you cannot go there and service a sensor regularly. The cost of servicing a sensor in the field sometimes, is higher than providing the service per se. So those are the areas, or those are the applications where low power, wide area networks come into play. Okay, so that is the reason for this part of the graph. And so the short range is also interchangeable with the low power. Okay, I'm now getting into the main part of the discussion. Quickly, we'll go through this. So basically, the features of low power, wide area networks are, and I explained this a little bit earlier, which is one is, of course, you have large distances through which the signal has to traverse. You're looking at very, very low data rates and very, very, very infrequent data being transmitted. And then you're looking at very, very low power consumption. So basically, we are looking at LPWA being attractive for those applications that require the connection of widely scattered devices which send occasional status updates. Okay? So here are some LPWAN technologies which are commonly available. Okay, I don't have any particular official interest in any of them, so I've just put them in some random order. It's not in any order of big to small or small to big or whatever else. But Sigfox has been in the news for quite some time. They've been working in this area for quite some time. Any idea, anybody remembers seeing Sigfox in the news recently? Okay, so Sigfox was in the news because they said they're rolling out a network, a low power wide area network across France recently. This is as of a couple of months back. A year or so back, they said we have covered Belgium. Okay, Belgium can be covered with one tower, whatever it is, okay? But it's a tower-based service. They actually operate more like a cellular network. And they provide low power, wide area networking. Weightless is another good service provider, open system, okay? And they are actually allowing open software to be integrated. And they operate in the sub-gigahertz unlicensed spectrum. Most of these technologies operate in the unlicensed spectrum. As you're aware, in the US, this is 868 megahertz. In Europe, it is 915 megahertz and thereabouts. Okay, so Link Labs also works on hardware, which they support two standards. One is they support the LoRa Alliance standard, which is here, and they have their own standard, which is called Symphony Link, which is their own solution. N-Wave operates off the ultra narrowband, and OnRamp, which is now called Ingenu, has a solution which works on RFMA. So basically, these are some of the leading ones, but this is not a comprehensive list. I can think of at least 2 or 3 more that could have made it here. I just didn't want to clutter up the slide with too much data. But if you do a little bit of search, or if you connect with me, I can actually point you to the other providers, most of them in the unlicensed spectrum. Okay, and here are some more that are coming. Now are the big ones. Okay, so you have the Narrowband Lt group, which comprises of Intel, Nokia, and Ericsson, and where they also believe that for IoT devices can we develop a standard. They're working on one. Here they are also looking at IoT devices which come with a mobility requirement. So far, whatever we discussed was more of static devices. Here are the mobile ones. Qualcomm is working on their own standard. The Wi-Fi Alliance is working on their own standard. And the GSMA, which has some 26 member association members in their association, including Vodafone, is working on a standard which works on the licensed spectrum itself, but which is tailor-made to low-power wide area networking. Just one word here from these two slides, which is, see, the fundamental difference between cellular networks is people assume that cellular networks come with a little bit more cost because there is a license fee to be paid and there is a service provider who's there at the other end of it. But then look at whether the solution that you are looking at, which can do well with an LPWAN kind of connectivity, whether that requires roaming, okay, whether that requires stuff like firmware upgrades over the air, whether you need repeaters to improve the signal in certain parts of the building, and so on. Okay, just keep that one little bit of a caveat in mind, and then you can make your choice. Or wait for a little bit. The GSMA standards are supposed to be announced in this month. I was actually hoping that they would have got announced so that we could talk about it a little bit today. They have not yet been announced. But in December, the announcement was made about GSMA in August, and they said the first version of standards would be out by December. Just stay put for that one. You'll get a better view of what is possible. This is what the GSMA does in LPWA. Basically, again, specific to the IoT, low power consumption, long range, licensed spectrum. They're also looking at providing, because of the footprint, they're also looking at devices that will be sub $5 per module. But don't jump for joy right now. That price will come with volumes, okay? And all these features that are listed here, including sufficient indoor penetration and everything else. One slide on the sweet spots for LPWA. I'm going a little faster just to make sure that I cover it up within the time allocated. You can look at parking space management, one of the examples which I gave earlier. Some little bit about, yes, madam. Okay, so I'm not the technology guy, but my understanding of low power is if a pair of AA batteries, your Pentorch batteries, can keep that device powered and active for 10 years plus. 10 years. That is, actually that was there in one of the slides on LP, the first slide, but it is 10 years plus is the life, okay? Some of the devices that we are testing actually have stated life of 20 years. So it's a little bit like fit and forget. You only have to hope that that technology still exists at 20 years. The sensor will still be transmitting. Okay, but basic metering, rainfall monitoring, facilities management, garbage bins tracking, that kind of stuff is doable on LPWA. Okay? Any questions? I'm sort of at the end of the LPWA. Yes, madam. You'll need to get a mic to her, yeah.
I think for the home, there is Zigbee standard.
Absolutely,
and
yes.
Also in terms of what about WiMAX, which really started and then LTE took off. What do you think of WiMAX and how that will apply for Indian context? And there are other tech, and each and everybody is looking. And Google is starting with Thread and then saying that my vision is to make sure that I have this networking for all transport, irrespective of the transport, IoT, VT, so many things are there. So where I didn't see any of those
yeah,
captured.
okay. And thank you for bringing that. So she's actually picked up something which is an omission in my presentation, but it was deliberate. The reason why I omitted talking of WiMAX and things like that was I was trying to focus the discussion down to low power. And typically WiMAX and all that require higher power. So that's why I sort of kept that out of the discussion. My sense is many of these technologies would still have a place in the Internet of Things, but they would have an appropriate place in that Internet of Things. I don't see Wi-Fi deployments growing WiMAX growing at that rate at which the kind of discussion is happening around LPWAN.
Zigbee, the 802.15.4, not necessarily Zigbee, but 802.15.4.
Yeah, Zigbee, I see, would continue to play a big part, especially for home automation within closed environments. And what we call as the equivalent of a LAN is where I see Zigbee, I can see Wi-Fi playing big roles there. I put those up because they are established technologies. All these, again, don't fit into the low power bracket. And that was the reason why I had not actually brought them up on a slide here. But they bear. Thank you for asking that question. Any questions on LPWAN? Because after this, I'm sort of getting into a conclusion, wrap-up kind of slide. Okay? Sorry, somebody said something. Yes, sir.
My question is specific to low power WAN. You're from IET, also from Vodafone. So as a network provider, what do you think a right WAN for Indian context?
Okay, good
Among
question.
all the things which you showed.
Thanks. See, my view is, and I go a little bit back to the gentleman who spoke first from Map Unity. Okay, so is that especially when it comes to standards and technologies, it is actually better to go with what the globe will consume or what the world will consume, simply because you will need to have sufficient traction in terms of number of people that adopt it. And so the answer which I'm giving you may not be local to India, but my view is that the GSMA standard, and I have some previews, just that I'm not able to share it in an open forum like this. The GSMA standard would address many of the requirements for low power wide area access without the constraints of interference which comes from unlicensed spectrum and so on and so forth. So just stay there for whatever time. My sense is it will take another couple of years before the whole dust settles down, because there's a lot of land grab and discussion going around on my standard is the best and yours is not the best and so on and so forth. Any meeting that we go to has a lot of debate and discussion on the various standards. But my sense is wait for the GSMA standard to come out. At least that will try to address some of the gaps in the other technologies that I discussed. It was supposed to be announced in December, so I'm just waiting for that announcement to happen. I am aware that we've done a little bit of a wrap-up and all that, so there is some broad agreement in the GSMA. Is it ready to be published as a standard? May not be, but whatever, give it another 10 days and we should have or 20 days. December is till 31st, right? Okay, one little slide on Vodafone. So Vodafone has a global presence, and which is one thing which we keep looking for. So even if it is, say, a car manufacturer in India, like Mahindra Reva, when we actually proposed a solution to them, we had kept in mind saying that at some point you would have a requirement for the solution to work across the globe. And that's exactly what is happening with Reva. Reva is now getting exported to Europe, and they're saying we are glad that you forced us to build these features into our module, the connectivity module, because now it works well in Europe. So we are a global telecom service provider. We have a separate M2M practice. I actually lead that machine-to-machine, which is teleco speak for Internet of Things. I lead that practice for India. And we actually have more than 1,300 people who are focused purely on the M2M practice, who are vertical experts, who are technology experts, who are industry specialists, who work with various customers. We work primarily with the enterprise and the government segment in this. You can do a little bit of Googling. I didn't want to do too much of pitching on Vodafone, primarily lack of time. You can do a check. So we are implementing a city project for in Spain. So you can Google on Vodafone. This is being done in conjunction with IBM in Santander and Andalusia. Yes, sir. Oh, okay. Thank you for asking that question. And thank you for clarifying. Okay. So my answer was not to say that we are not focused on transportation. My answer was in the context of, see, I wear two hats, right? So I didn't know which hat you were addressing. So you were actually addressing the Vodafone hat when I was answering using IET hat. In Vodafone, we are the global leaders in automotive. We have a separate company called Vodafone Automotive, which focuses purely on transportation. We have a company. And we, as a telco, we don't manufacture mobile phones, we don't manufacture radios, we don't manufacture tower equipment, we don't manufacture fiber, but we manufacture parking sensors, we manufacture burglary alarms, and stuff like that. So we have a separate focus on transportation itself. The last one, okay. So smart city requirements will grow explosively. That's one thing which I wanted to land it here. The current cellular technologies are not geared to address this requirement. That also I confess. But then there are standards which are on our way. The current cellular network also comes with its own cost and security requirements, which may not be required in an IoT thing. You don't need to really bill somebody on a monthly basis for a sensor which is lying, measuring rainfall and stuff like that. So many of these high-cost elements need not be there. So which is why we are very, very gung-ho about this effort. And we can use LPWAN to plug many of the gaps in this. Okay. Just keep an eye open for functions like OTA, retries, roaming, and stuff like that. And this is a prediction from the Machina research, and this is my last slide. which is we see that the LP WAN will actually add a significant chunk to the growth of machine-to-machine itself, which is this little piece which I had highlighted here. It will actually add quite a bit to the growth of the Internet of Things. Thank you. These are my coordinates. And if there are any last questions, I'll take them now. I'll take just 3 questions in the interest of time. I have this little thing which says time's up in red color, okay? So, okay, sorry. We'll do this over coffee, okay? I'm available here. Let's break up and catch up over coffee. Thank you. Thank you.